Eric Schmidt gave a fascinating talk at Stanford just a few days ago about AI. He was, of course, the former Google CEO and perceived by people as a bit of a futurist. He's able to kind of often very accurately predict where technology is going. The interview was over an hour long and was fascinating, covering topics like AI agents, where this whole thing is going, etc., and had a lot of pretty brilliant insights by Eric into where he believes this is going. But unfortunately, in that hour-plus long interview, there was just one comment that people didn't like. The media machine went into overdrive mode, and the video has been basically taken down. It's no longer available to see. It was deemed too hot for the internet and no longer available, but just between you and me, and keep this on the DL, please, I might have a copy of it. Maybe. Allegedly. I feel like I need to say something here that reduces my liability. Some sort of a legal statement like, I take no responsibility for my actions. Yeah, that should do it.
Subscribe for more sweet AI content.
Let's take a look at a few clips from this Stanford lecture by Eric Schmidt about AI. I think you will like it. If you do, hit that thumbs up, please, because this is somebody that has a bit of a clairvoyance about the future of tech. He tends to see how things will unfold with startling accuracy. So before he starts talking, he asks the class to basically define what a context window is and what AI agents are. Context windows, of course, you can think of it as sort of a short-term memory. It's basically the amount of words that a large language model can read and also write and output and kind of interact with, right? So if it has a large context window, you can give it a whole book and then ask it questions about the book. If it has a very short context window, we might start answering a question and then halfway through forget what it was talking about. It will be kind of a whoops, I ran out of memory type of thing. And AI agents are things that can sort of complete tasks on your behalf. You can tell them to go order something off of Amazon. They'll go, they'll search, they'll do reviews, they'll check the sizes, the colors, whatever, and then order it and then report that they've done it back to you. So you can think of it as kind of a smart intern that's online, that's AI. And Eric is talking about potentially us seeing a 10 million token context window sometime soon, potentially in the next 2 years or so. He doesn't specify a timeline, but soon. So the first thing he talks about is what are we going to expect to happen in the next 2 to 5 years, so in the short term. Specifically at the intersection of something like a 10 million token context window and improving autonomous AI agents. Take a listen.
So an agent is something that does some kind of a task. Another definition would be that it's an LLM, state in memory. Okay. Can anybody, again, computer scientists, can any of you define text to action? Taking text and turning it into an action? Right here. Go ahead.
Yes. Instead of taking text and turning it into more text.
More text.
Taking text and have the AI trigger actions based on
it. So another definition would be language to Python. A programming language I never wanted to see survive. And everything in AI is being done in Python. There's a new language called Mojo that has just come out, which looks like they finally have addressed AI programming, but we'll see if that actually survives over the dominance of Python. One more technical question. Why is NVIDIA worth $2 trillion and the other companies are struggling? Technical answer.
I think it just boils down to like most of the code needs to run with CUDA optimizations that currently only NVIDIA GPU supports. So other companies can make whatever they want to, but unless they have the 10 years of software there, you don't have the machine learning optimizations running.
I like to think of CUDA as the C programming language for GPUs.
Yeah.
Right. That's the way I like to think of it. It was founded in 2008. I always thought it was a terrible language, and yet it's become dominant. There's another insight. There's a set of open source libraries which are highly optimized to CUDA and not anything else. And everybody who builds all these stacks, right, this is completely missed in any of the discussions. Right. It's technically called VLLM, and a whole bunch of libraries like that. Highly optimized CUDA. Very hard to replicate that if you're a competitor. So what does all this mean? In the next year, you're going to see very large context windows, agents, and text to action. When they are delivered at scale, it's going to have an impact on the world at a scale that no one understands yet. Much bigger than the horrific impact we've had by social media, right, in my view. So here's why. In a context window, you can basically use that as short-term memory. And I was shocked that context windows get this long. The technical reasons have to do with the fact that it's hard to serve, hard to calculate, and so forth. The interesting thing about short-term memory is when you feed, you ask it a question, read 20 books, you give it the text of the books is the query, and you say, tell me what they say. It forgets the middle, which is exactly how human brains work too, right? That's where we are. With respect to agents, there are people who are now building essentially LLM agents, and the way they do it is they read something like chemistry, they discover the principles of chemistry, and then they test it, and then they add that back into their understanding, right? That's extremely powerful. And then the third thing, as I mentioned, is text to action. So I'll give you an example. The government is in the process of trying to ban TikTok. We'll see if that actually happens. If TikTok is banned, here's what I propose each and every one of you do. Say to your LLM the following. Make me a copy of TikTok, steal all the users, steal all the music, put my preferences in it, produce this program in the next 30 seconds, release it, and in 1 hour, if it's not viral, do something different along the same lines. That's the command. Boom, 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 right? You understand how powerful that is. If you can go from arbitrary language to arbitrary digital command, which is essentially what Python in this scenario is, imagine that each and every human on the planet has their own programmer that actually does what they want, as opposed to the programmers that work for me who don't do what I ask.
Or potentially a whole army of AI influencers, each with its own little tweak that are completely managed by these AI agents, all trying to fill a certain niche, a certain gap, a certain personality type. You can have an infinite amount of them, posting 24 hours a day.
The programmers here know what I'm talking about. So imagine a non-arrogant programmer that actually does what you want, and you don't have to pay all that money to. And there's infinite supply of these programs.
And this is all within the next year or two.
Very soon. Those three things, and I'm quite convinced it's the union of those three things that will happen in the next wave. So you asked about what else is going to happen. Every 6 months I oscillate. So it's an even odd oscillation. So at the moment, the gap between the frontier models, of which there are now only three, I'll review who they are, and everybody else, appears to me to be getting larger. 6 months ago, I was convinced that the gap was getting smaller. So I invested lots of money in the little companies. Now I'm not so sure. And I'm talking to the big companies, and the big companies are telling me that they need 10 billion, 20 billion, 50 billion, 100 billion.
Stargate is 100 billion, right?
They're very, very hard. I talked to Sam Altman.
Stargate is Microsoft and OpenAI's sort of co-project where they plan to invest $100 billion into a data center. And by the way, that's not the only project where they're kind of working together. The other one is the power plant, the fusion power plant, somewhere near Seattle, Washington, in that area, that they hope could potentially provide a lot of, maybe not unlimited energy, but clean, cheap, inexpensive energy to power a lot of this stuff. Next, he's talking about what he and Sam Altman talked about.
Sam Altman is a close friend. He believes that it's going to take about 300 billion, maybe more. I pointed out to him that I'd done the calculation on the amount of energy required. And I then, in the spirit of full disclosure, went to the White House on Friday and told them that we need to become best friends with Canada. Because Canada has really nice people, helped invent AI, and lots of hydropower. Because we as a country do not have enough power to do this.
Keep in mind, too, that there's a lot of sort of heat generated in these processes. So the need to cool these buildings, these infrastructures, if you're running it somewhere where it's hot, you also have to consider your AC bill. Running it somewhere where it's naturally cold could be very, profitable. You would greatly slash your costs because you don't have to worry about cooling, or at least not as much.
The alternative is to have the Arabs fund it. And I like the Arabs personally. I spent lots of time there, right? But they're not going to adhere to our national security rules, whereas Canada and the US are part of a triumvirate where we all agree on.
So these $100 billion, $300 billion data centers, electricity starts becoming the scarce resource.
Well, and by the way, if you follow this line of reasoning, why did I discuss CUDA and NVIDIA? If $300 billion is all going to go to NVIDIA, you know what to do in the stock market. Okay.
That sounds like he's recommending people buy NVIDIA.
Not a stock recommendation. I'm not a licensed.
Well, part of it, so we're getting a lot more chips, but Intel is getting a lot of money from the U.S. government, AMD, and they're trying to build, fabs in Korea.
Raise your hand if you have an Intel computer in your Intel chip in any of your computing devices. Okay, so much for the monopoly.
Well, that's the point, though. They once did have a monopoly.
Absolutely.
And NVIDIA has a monopoly now. So are those barriers to entry, like CUDA, is there something that so I was talking to Percy Lang the other day, he's switching between TPUs and NVIDIA chips, depending on what he can get access.
So for those who are not aware, one big race that's happening right now is kind of the race to produce these chips that power AI growth. And NVIDIA has been kind of you can say the undisputed leader in the field, producing GPUs, graphical processing units. And those have been very effective. They kind of started with, computer games acceleration, because instead of running each process kind of independently, finishing it and running the next one, which could create bottlenecks, it runs them in parallel. So for example, if you're rendering a game on screen, right, you have some crazy 3D game with solar arrays and whatever that's running in, 30 frames per second, 60 frames per second. You know what I mean? You need to be able to render each pixel on the screen in real time. You can't wait for it to get rendered. You have to kind of render it all in parallel. And GPUs were really good at that. That's part of the power of why NVIDIA is so powerful, as well as CUDA, the programming language that they run on. But we do have other alternatives for these AI chips. The TPU, the Tensor Processing Unit, is Google's creation. Recently, we've also seen Grok, which is something that they refer to as a language processing unit, and LPU. There's been some talk of neuromorphic chips, which are more designed like the human brain. They're not digital, they're more analog, but I don't know if any progress has been made in that field. And it sounds like Sam Altman is cooking up a brand new chip that might eventually go on to compete with NVIDIA. That's still in the very early stages, but That's the big question. Is NVIDIA going to continue to dominate, or is somebody going to come out with something that's brand new and much, much better for AI specifically? Because GPUs aren't necessarily the best possible sort of architecture for AI. They happen to be very good. They happen to be the best thing we have right now, but nothing's to say that some different architecture can't be a million times better just because it's built from scratch for AI inference and training.
Absolutely.
And NVIDIA has a monopoly now. So are those barriers to entry, like CUDA, is there something that so I was talking to Percy Lang the other day, he's switching between TPUs and NVIDIA chips depending on what he can get access to.
That's because he doesn't have a choice. If he had infinite money, he would pick the B200 architecture out of NVIDIA because it would be faster. And I'm not suggesting, it's great to have competition. I've talked to AMD and Lisa Su at great length. They have built a thing which will translate from this CUDA architecture that you were describing to their own, which is called ROCm. It doesn't quite work yet. They're working on it.
So Lisa Su, that's of AMD, so one of the NVIDIA's competitors.
AMD and Lisa Su at great length. They have built a thing which will translate from this CUDA architecture that you were describing to their own, which is called ROCm. It doesn't quite work yet.
That get transcribed as CUDA architecture, but that's not what it is. He's saying CUDA architecture, CUDA, so the NVIDIA's sort of architecture versus ROCm. I'm not familiar with that one. I guess that's AMD's version of CUDA.
You were at Google for a long time, and they invented the transformer architecture.
Peter. It's all Peter's fault.
Thanks to brilliant people over there like Peter and Jeff Dean and everyone. But now it doesn't seem like they've kind of lost the initiative.
So I guess this is the part that caused all the hubbub. I'm just skipping it. I'm not touching it. It's not really related to AI necessarily. Unfortunately, I think there's a lot of overlap with politics, so I'm just trying to avoid that. But it seems like he's saying that it might be like a cultural issue. But let's continue and see what else they've talked about.
Yes, sir.
In terms of national security or geopolitical interest, how do you think AI is going to play a role or competition with China as well?
So I was the chairman of an AI commission that sort of looked at this very carefully. And you can read it. It's about 752 pages. And I'll just summarize it by saying, we're ahead, we need to stay ahead, and we need lots of money to do so. Our customers were the Senate and the House. And out of that came the CHIPS Act and a lot of other stuff like that. A rough scenario is that
the CHIPS Act invested billions into building out the U.S. infrastructure to develop AI chips. And also, I believe that's what limited a lot of the NVIDIA's export to China. Some of the best chips, the most powerful chips, it limited the exports to China, how much they could ship and sell in China. How it seems like that's creating a bit of a black market of people trying to import those into China through other means. But
if you assume the frontier models drive forward and a few of the open source models, it's likely that a very small number of countries can play this game. What are those countries, or who are they? Countries with a lot of money, and a lot of talent, strong educational systems, and a willingness to win. The US is one of them. China's another one. How many others are there?
Are there any others?
I don't know, maybe. But certainly in your lifetimes, the battle between the US and China for knowledge supremacy is going to be the big fight. Right? So the US government banned essentially the NVIDIA chips, although they weren't allowed to say that was what they were doing, but they actually did that into China. They have about a 10-year chip advantage. We have a roughly 10-year chip advantage in terms of sub-DUV, that is sub 5 nanometers.
10 years, that's
roughly 10 years.
Wow.
And so you're going to have, so an example would be, today we're a couple of years ahead of China. My guess is we'll get a few more years ahead of China, and the Chinese are whopping mad about this. It's like hugely upset about it. So that's a big deal. That was a decision made by the Trump administration and furthered by the Biden administration.
Do you think that it's going to make that scale of investment? I mean, obviously the CHIPS Act, but beyond that, building a massive AI system?
So as you know, I lead an informal, ad hoc, non-legal group. That's different from illegal.
That's exactly, just to be clear.
Which includes all the usual suspects.
Yes.
And the usual suspects over the last year came up with the basis of the reasoning that became the Biden administration's AI Act, which is the longest presidential directive in history.
You're talking about the Special Competitive Studies Project?
No, this is the actual act from the executive office. Okay. And they're busy implementing the details. So far, they've got it right. And so, for example, one of the debates that we had for the last year has been, how do you detect danger in a system which has learned it, but you don't know what to ask it? Okay. So in other words, it's a sort of a core problem. It's learned something bad, but it can't tell you what it learned, and you don't know what to ask it. And there's so many threats, right? Like it learned how to mix chemistry in some new way, but you don't know how to ask it. And so people are working hard on that. But we ultimately wrote in our memos to them that there was a threshold which we arbitrarily named as 10 to the 26 flops, which technically is a measure of computation. That above that threshold, you had to report to the government that you were doing this. And that's part of the rule. The EU, to just make sure they were different, did it at 10 to the 25.
Yeah.
But it's all kind of close enough. I think all of these distinctions go away because the technology will now, the technical term is called federated training, where basically you can take pieces and union them together. So we may not be able to keep people safe from these new
Well,
threats.
rumors are that that's how OpenAI has had to train, partly because of the power consumption. There's no one place where they did.
So this is interesting. I haven't heard that specific terminology before. So he's saying that you can kind of build different pieces of LLMs or sort of AI systems. You train those pieces separately and then you union them together, you glue them together. We've seen this with the recent paper published where you can take sort of the large smart model and a very like a cheaper, faster model and have sort of another sort of gatekeeper, yet another AI model that kind of chooses where it routes the questions to. So certain questions need to be answered by the bigger model, but there's a lot that can be answered just as effectively by the smaller model. And so this model just routes them to the cheaper model when needed. And the results have been astonishing because it's, if I remember my numbers correctly, it has shown in some cases to reduce the costs of running these things by 80% while maintaining something like 96% accuracy. So for just, and I don't recall those are the exact numbers, but it was some big numbers like that. So it's a tiny reduction in accuracy for a potentially massive reduction in cost. So I'm not sure if that's an example of specifically what he's talking about, but this idea of federated training sounds like it's training pieces in individual sort of batches, right? And taking those pieces and then putting them together to create the final model. Next, we're talking about war.
Well, let's talk about a real war that's going on. I know that something you've been very involved in is the Ukraine war, and in particular, the Ukraine war, and in particular, I don't know how much you can talk about White Stork and your goal of having $500 drones destroy $5 million tanks.
So
how's that changing warfare?
So I worked for the Secretary of Defense for 7 years and tried to change the way we run our military. I'm not a particularly big fan of the military, but it's very expensive, and I wanted to see if I could be helpful. And I think, in my view, I largely failed. They gave me a medal, so they must give medals to failure or whatever. But my self-criticism was nothing has really changed. And the system in America is not going to lead to real innovation. So watching the Russians use tanks to destroy apartment buildings with little old ladies and kids just drove me crazy. So I decided to work on a company with your friend, Sebastian Thrun, and as a former faculty member here, and a whole bunch of Stanford people. And the idea basically is to do two things. Use AI in complicated, powerful ways for these essentially robotic war. And the second one is to lower the cost of the robots. Now you sit there and you go, why would a good liberal like me do that? And the answer is that the whole theory of armies is tanks, artillery, and mortar, and we can eliminate all of them. And we can make the penalty for invading a country, at least by land, essentially be impossible. It should eliminate the kind of land battles.
Well, this is a really interesting question. Is that does it give more of an advantage to defense versus offense? Can you even make that distinction?
Because I've been doing this for the last year, I've learned a lot about war that I really did not want to know. And one of the things to know about war is that the offense always has the advantage because you can always overwhelm the defensive systems. And so you're better off as a strategy of national defense to have a very strong offense that you can use if you need to. And the systems that I and others are building will do that. Because of the way the system works, I am now a licensed...
I think he might have misspoken there. Let me know in the comments if you think so too, or I'm missing something. I think he meant to say that he and others like him will build incredible defensive systems to reduce the effectiveness of invading and using offensive systems. That's how I'm interpreting. I think he kind of, to me, it sounds like he misspoke a little bit, if I understand correctly.
Because of the way the system works, I am now a licensed arms dealer. Others are building will do that. Because of the way the system works, I am now a licensed arms dealer. So computer scientist, businessman, arms dealer. And I'm sorry to say.
Is that a progression?
I don't know. I do not recommend this in your career path. I stick with AI. And because of the way the laws work, we're doing this privately, and then this is all legal with the support of the governments. It goes straight into the Ukraine, and then they fight the war. And without going into all the details, things are pretty bad. I think if in May or June, if the Russians build up as they are expected to, Ukraine will lose a whole chunk of its territory and will begin the process of losing the whole country.
So I believe this was recorded in August 2024, just a few days ago, or at least that's when it was posted. If you recall the news headlines about it, all of them are from like a few hours ago. So I think he's talking about 2025. I'm assuming, so he's talking about May or June of 2025.
For most of history, humans sort of had a mystical understanding of the universe, and then there's the scientific revolution and the Enlightenment. And in your article, you argue that now these models are becoming so complicated and difficult to understand that we don't really know what's going on in them. I'll take a quote from Richard Feynman. He says, "What I cannot create, I do not understand." I saw this quote the other day. But now people are creating things that they can create, but they don't really understand what's inside of them. Is the nature of knowledge changing in a way? Are we going to have to start just taking the word for these models without them being able to explain it to us?
The analogy I would offer is to teenagers. If you have a teenager, you know they're human, but you can't quite figure out what they're thinking. But somehow we've managed in society to adapt to the presence of teenagers, right? And they eventually grow out of it. And it's serious. So it's probably the case that we're going to have knowledge systems that we cannot fully characterize, but we understand their boundaries, right? We understand the limits of what they can do. And that's probably the best outcome we can get.
Do you think we'll understand the limits?
we'll get pretty good at it. The consensus of my group that meets on every week is that eventually the way you'll do this, so-called adversarial AI, is that there will actually be companies that you will hire and pay money to break your AI system.
Like red team.
So it'll be instead of human red teams, which is what they do today, you'll have whole companies and a whole industry of AI systems whose jobs are to break the existing AI systems and find their vulnerabilities, especially the knowledge that they have that we can't figure out. That makes sense to me. It's also a great project for you here at Stanford, because if you have a graduate student who has to figure out how to attack one of these large models and understand what it does, that is a great skill to build the next generation. So it makes sense to me that the two will travel together.
If that's something that interests you, there's a Twitter/X account, Pliny the Prompter, who basically jailbreaks a lot of these models, usually within a few days of their release. So he's just, of course, one of many people that do sort of things like that. He does it kind of seemingly for entertainment and for online media clout. But if you think about it, third-party testing, third-party red teaming of AI models, third-party quality assurance, right, QA, of these models as they roll out and have contact with consumers, with businesses, with organizations, et cetera, as well as just with various infrastructure systems and factories, automations, et cetera, war, of course, that's going to be a big industry that doesn't really exist yet. It just is beginning to grow. And yeah, that might be something interesting and profitable to get into if that's your cup of tea. Next, he comments just a bit on adversarial AI.
You just mentioned adversarial AI. I'm wondering if you could elaborate on that more. So it seems to be, besides obviously compute will increase and you get more performant models, but is getting them to do what you want issue seems totally unanswered in my view.
Well, you have to assume that the current hallucination problems become less, right, as the technology gets better and so forth. I'm not suggesting it goes away. And then you also have to assume that there are tests for efficacy. So there has to be a way of knowing that the thing succeeded. So in the example that I gave of the TikTok competitor, and by the way, I was not arguing that you should illegally steal everybody's music. What you would do if you're a Silicon Valley entrepreneur, which hopefully all of you will be, is if it took off, then you'd hire a whole bunch of lawyers to go clean the mess up, right? But if nobody uses your product, it doesn't matter that you stole all the content. And do not quote me, right?
Right? You're on camera.
Yeah, that's right.
Quoting you.
But you see my point. In other words, Silicon Valley will run these tests and clean up the mess. And that's typically how those things are done. So my own view is that you'll see more and more performative systems with even better tests and eventually adversarial tests, and that'll keep it within a box. The technical term is called chain of thought reasoning. And people believe that in the next few years, you'll be able to generate 1,000 steps of chain of thought reasoning, right? Do this, do this. It's like building recipes, right? That the recipes, you can run the recipe and you can actually test that it produced the correct outcome. And that's how the system will work.
Next, they ask, what's going to be driving AI progress? Is it more data, more compute? Is it just like chips and hardware?
The amounts of money being thrown around are mind-boggling. And I essentially invest in everything because I can't figure out who's going to win. And the amounts of money that are following me are so large. I think some of it is because the early money's been made and the big money people who don't know what they're doing have to have an AI component. And everything is now an AI investment, so they can't tell the difference. I define AI as learning systems that actually learn. So I think that's one of them. The second is that there are very sophisticated new algorithms that are sort of post-transformers. My friend, my collaborator for a long time, has invented a new non-transformer architecture. There's a group that I'm funding in Paris that has claims to have done the same thing. So there's enormous invention there, a lot of things at Stanford. And the final thing is that there is a belief in the market that the invention of intelligence has infinite return. So let's say you put $50 billion of capital into a company. You have to make an awful lot of money from intelligence to pay that back.
I mean, when you phrase it like that, it seems to make sense. If you invent intelligence, certainly that would have an infinite return.
So it's probably the case that we'll go through some huge investment bubble, and then it'll sort itself out. That's always been true in the past, and it's likely to be true here.
And what you said earlier was you think that the leaders are pulling away from the rest.
Right now. And this is a really, the question is roughly the following. There's a company called Mistral in France. They've done a really good job. And I'm obviously an investor. They have produced their second version. Their third model is likely to be closed because it's so expensive. They need revenue, and they can't give their model away. So this open source versus closed source debate in our industry is huge. And my entire career was based on people being willing to share software in open source. Everything about me is open source. Much of Google's underpinnings were open source. Everything I've done technically. And yet it may be that the capital costs, which are so immense, fundamentally changes how software is built. You and I were talking, my own view of software programmers is that software programmers' productivity will at least double. There are 3 or 4 software companies that are trying to do that. I've invested in all of them in the spirit. And they're all trying to make software programmers more productive. The most interesting one that I just met with is called Augment. And I always think of an individual programmer, and they said, that's not our target. Our target are these 100-person software programming teams on millions of lines of code where nobody knows what's going on. Well, that's a really good AI thing. Will they make money?
Yeah.
I hope so.
You mentioned that there's the combination of the context window expansion, the agents, and the text to action is going to have unimaginable impacts. First of all, why is the combination important? And second of all, I know that you're not like a crystal ball and you can't necessarily tell the future, but why do you think it's beyond anything that we could imagine?
I think largely because the context window allows you to solve the problem of recency. The current models take a year to train, roughly there's 18 months, 6 months of preparation, 6 months of training, 6 months of fine tuning. So they're always out of date. Context window, you can feed what happened. Like you can ask it questions about the Hamas-Israel war, right, in a context. That's very powerful. It becomes current like Google. In the case of agents, I'll give you an example. I set up a foundation, which is funding a nonprofit, which starts, I don't know if there's chemists in the room, I don't really understand chemistry. There's a tool called ChemCrow, C-R-O-W, which was an LLM-based system that learned chemistry. And what they do is they run it to generate chemistry hypotheses about proteins, and they have a lab which runs the tests overnight, and then it learns. That's a huge accelerant in chemistry, material science, and so forth. So that's an agent model. And I think the text to action can be understood by just having a lot of cheap programmers, right? And I don't think we understand what happens, and this is, again, your area of expertise, what happens when everyone has their own programmer. And I'm not talking about turning on and off the lights. I imagine, another example, for some reason you don't like Google. So you say, build me a Google competitor. Yeah, you personally, you don't build me a Google competitor, search the web, build a UI, make a good copy, add generative AI in an interesting way, do it in 30 seconds, and see if it works, right? So a lot of people believe that the incumbents, including Google, are vulnerable to this kind of an attack. Now, we'll see.
There were a bunch of questions that were sent over by Slido. I want to give some of them were uploaded. So here's one. We talked a little bit about this last year. How can we stop AI from influencing public opinion, misinformation, especially during the upcoming election?
He's asked a bit about misinformation. How can we prevent AI from causing misinformation? He talks about how during his time working with YouTube, that was a problem. People would upload a video for profit, for their own self-gain. And as a result of misinformation, he says, well, people could be hurt. He even says people die. So certainly that is a problem. If you saw my yesterday's video about Grok 2 and the images it generates, they're very real looking, and Grok 2 does not seem to have any sort of safety rails in place. It just generates whatever you ask for. So heading into this election, certainly that could be an issue. He talks a little bit about some sort of a digital authentication or a public key authentication. Basically, if somebody like the president speaks, there's some key that everybody else can verify saying, okay, this is him, this is his original audio. He mentions briefly that it seems like he's saying it's a shame that the American universities aren't getting as much resources for compute, for Google Cloud and other places like that. In this explosion where all the big companies are basically gobbling up the available resources. And so he's saying the right thing for us to do is to get them the resources they need, to give the universities the compute, the resources that they need to pursue research and development and all that stuff. Next, they talk about automation. Who's getting replaced? Who's getting to be obsolete in the labor force? So let's take a look at that really fast.
I'll defer to the real expert here. As your amateur economist taught by Eric, I fundamentally believe that the sort of college education, high skills task will be fine because people will work with these systems. I think the systems is no different from any other technology wave. The dangerous jobs and the jobs which require very little human judgment will get replaced.
The next question is kind of about like the global balance of AI power. So the person asking the question specifically mentions US and China. But as you see here, Eric specifically focuses on India. Take a listen.
The most interesting country is India because the top AI people come from India to the US. And we should let India keep some of its top talent, not all of them, but some of them. And they don't have the kind of training facilities and programs that we so richly have here. To me, India is the big swing state in that regard. China's lost. It's not going to come back. They're not going to change the regime as much as people wish them to do. Japan and Korea are clearly in our camp. Taiwan is a fantastic country whose software is terrible, so that's not going to work. Amazing hardware. And in the rest of the world, there are not a lot of other good choices that are big. Europe is screwed up because of Brussels. It's not a new fact. I spent 10 years fighting them. And I worked really hard to get them to fix the EU Act, and they still have all the restrictions that make it very difficult to do our kind of research in Europe. My French friends have spent all their time battling Brussels, and Macron, who's a personal friend, is fighting hard for this. And so France, I think, has a chance. I don't see Germany coming, and the rest is not big enough. Yes, ma'am?
So I know you're an engineer by training, and I think a compiler. Given the capabilities that you envision these models having, should we still spend time learning to code?
Yeah, because ultimately it's the old thing of why do you study English if you can speak English? You get better at it, right? You really do need to understand how these systems work, and I feel very strongly. Yes, sir?
Yeah, I'm curious if you've explored
Good answer.
Distributed setting, and I'm asking because, sure, like making a large cluster is difficult, but MacBooks are powerful. There's a lot of small machines across the world. So like, do you think like folding at home or a similar idea works for training AI systems?
Yeah, we've looked very hard at this. So the way the algorithms work is you have a very large matrix, and you have essentially a multiplication function. So think of it as going back and forth and back and forth. And these systems are completely limited by the speed of memory to CPU or GPU. And in fact, the next iteration of NVIDIA chips has combined all those functions into one chip. The chips are now so big that they glue them all together. And in fact, the package is so sensitive that the package is put together in a clean room as well as the chip itself. So the answer looks like supercomputers and speed of light, especially memory interconnect, really dominated. So I think unlikely for a while.
Is there a way to segment the LLM? Like, so Jeff Dean last year when he spoke here talked about having these different parts of it that you would train separately and then kind of federate them.
each, in order to do that, you'd have to have 10 million such things, and then the way you would ask the questions would be too slow. He's talking about 8 or 10 or 12.
So not down the level.
Not at his level.
Yeah.
Is he in the back? Yes, way back.
I know, like after ChatGPT was released in the New York Times sued OpenAI for using their works for training. Where do you think that's going to go and what that means for data
So
privacy?
I used to do a lot of work on the music licensing stuff. What I learned was that in the 60s, there was a series of lawsuits that resulted in an agreement where you get a stipulated royalty whenever your song is played. Even they don't even know who you are. It's just paid into a bank. And my guess is it'll be the same thing. There'll be lots of lawsuits, and there'll be some kind of stipulated agreement, which will just say you have to pay X% of whatever revenue you have in order to use that.
ASCAP, EMI.
ASCAP, EMI. Look them up. It's long. It will seem very old to you, but I think that's how it will ultimately. Yes, sir.
Interesting.
It seems like there's a few players that are dominating AI, right? And they'll continue to dominate. And they seem to overlap with the large companies that all the antitrust regulation is kind of focused on. How do you see those two trends kind of, do you see regulators breaking up these companies, and how will that affect
So in my career, I helped Microsoft get broken up, and it wasn't broken up. And I fought for Google to not be broken up, and it's not been broken up. So it sure looks to me like the trend is not to be broken up. As long as the companies avoid being John D. Rockefeller the senior, and I studied this, look it up, it's how antitrust law came. I don't think the governments will act. The reason you're seeing these large companies dominate is who has the capital to build these data centers, right? So my friend Reed and my friend Mustafa
He's coming next week, 2 weeks from now.
have Reed talk to you about the decision that they made to take Inflection.
So I believe Mustafa is talking about Mustafa Suleiman, who is the co-founder of Google DeepMind.
My friend Reed and my friend Mustafa
coming next week, 2 weeks from now.
have Reed talk to you about the decision that they made to take Inflection and essentially piece part it into Microsoft. Basically, they decided they couldn't raise the tens of billions of dollars.
Is that number public that you mentioned earlier?
Have Reed, you could say,
You got to go. I don't want to do it.
should we do one? This
One more. Yeah, go ahead. I was wondering where all of this is going to leave countries who are involved participants in development of frontier models and access to compute, for example.
The rich get richer, and the poor do the best they can. They'll have to. The fact of the matter is, this is a rich country's game, right? Huge capital, lots of technically strong people, strong government support, right? There are 2 examples. There are lots of other countries that have all sorts of problems. They don't have those resources. They'll have to find a partner. So they'll have to join with somebody else, something like that.
I want to leave it because I think the last time we met you, you were
He's fairly blunt. He's fairly straightforward. He, I think, kind of calls it how he sees it. And it really seems like he's not talking one side or the other. He's not pumping his bag, so to speak. So he's not saying the things that benefit his portfolio or whatever. He's just like, yeah, this is how it's going to be. This is how it works by default. Big companies are not going to broken up. The rich get richer, etc. And finally, he's asked a little bit more about kind of the business and entrepreneur side of things. If you're starting your own company, you have a product idea, what does that look like? How do you develop it? How do you create a lot of wealth with your own product? Here's his answer.
I want to leave it because I think the last time we met you, you were at a hackathon at AGI House, and I know you spend a lot of time helping like young people as they create a lot of wealth. And you spoke very passionately about wanting to do that. Do you have any advice for folks here as they're building they're writing their business plans for this class, or policy proposals, or research proposals? At this stage of the careers going forward.
Well, I teach a class in the business school on this, so you should come to my class. I am struck by the speed with which you can build demonstrations of new ideas. So in one of the hackathons I did, the winning team. The command was fly the drone between 2 towers, and it was given a virtual drone space. And it figured out how to fly the drone, what the word between meant, generated the code in Python, and flew the drone in the simulator through the tower. It would have taken a week or 2 from good professional programmers to do that. I'm telling you that the ability to prototype quickly, really, part of the problem with being an entrepreneur is everything happens faster. Well, now, if you can't get your prototype built in a day using these various tools, you need to think about that, right? Because that's who your competitor is doing. So I guess my biggest advice is when you start thinking about a company, is find the right business plan. In fact, you should ask the computer to write your business plan for you. As long as
I should talk about that after you leave it.
But I think it's very important to prototype your idea using these tools as quickly as you can, because you can be sure there's another person doing exactly that same thing in another company, in another university, in a place that you've never been.
All right. Well, thank you for sharing the workshop.
Very cool. So this piece was taken down. So apparently it's not even online right now, but hopefully those few little clips give you a glimpse about what he thinks of AI. I've kind of cut out all the pieces that I think caused the controversy or whatever that situation was. I don't think it really had anything to do with AI or anything of substance. I mean, maybe touched on some political issues, but whatever. This is a person with a lot of really technical background. And even though he's more of like a business guy, he is spoken of with a lot of respect by all the engineers and all the very highly technical people in the Bay Area and the Silicon Valley. He's somebody that really understands the tech space. Looks like Forbes has him listed as having a net worth of almost $24 billion. He's good friends, he said, with Sam Altman, president of France. Sounds like he knows all the co-founders of various AI companies, big and small. I mean, this is somebody that's very, very on the inside. This is somebody that knows where things are going. So certainly when he says something, I tend to listen. I put a great deal of weight into what he's saying. And what he's saying is this AI wave is just starting. We have two massive countries, two big countries with the capital and the talent and everything else that's needed that are vying for AI supremacy. The issues with the chips and the power and the data, while those are bottlenecks, it seems like they will slowly be, perhaps even maybe not that slowly, but be improved. He mentioned building data centers and various other AI infrastructure in Canada, potentially, which makes a lot of sense if you think about it. Lots of open land. It tends to be colder, which again, heating and the generation of heat and having to cool these facilities is a concern. Tons of land, very friendly government to the US. In Factorio, how do you just find a big chunk of the map where there's a lot of open land and you'd build all your nuclear power plants. You'd build out your entire electricity infrastructure there. You just have a cable going back to where you need the electricity to be. It begs the question, is this the future of Canada? I'm only kidding, of course, folks. But the more and more I think about it, there is a lot of land, it's close by, and it's cold. And certainly that would be phenomenal for the revenue of Canada to generate some sort of tax, some sort of revenue based on one of the kind of superpowers building out the infrastructure it needs to stay dominant in the AI race, right? I mean, they're talking about creating $100 billion data centers, potentially even the estimates as high as $300 billion. So that's one company. That's not even the US government supported projects. That's just a publicly traded company doing that. Sounds like he's really believing in NVIDIA and the power of NVIDIA and its CUDA sort of software that the chips run on. And if I'm understanding him correctly, he's not really seeing any competition to that. I mean, there's some things on the horizon, maybe, possibly, but nothing yet. So it sounds like a lot of this money, like a lot of it, will be flowing into NVIDIA. And of course, this idea that as the context window expands, it'll become more and more sort of similar to training in a sense that, right, if it takes a while to train up a model, but it can do in-context learning, meaning that you're able to just upload books and stuff to the finished model and it's able to learn from them, which we've seen that with Gemini. They found a language that doesn't have a lot of online presence. Only something like 24 people in the world speak it, but they have some notebooks and manuscripts and stuff like that. They uploaded to Gemini the actual finished trained Gemini, and that model was able to learn how to speak it, how to create sentences in it. It wasn't trained on it. It was learned in context, right? So as the context window ramps up to 10 million tokens, that certainly seems like it would change how we think about pre and post training. Or in other words, once the model is trained, it doesn't stop learning. If you wanted to learn about a specific thing that you wanted to learn about, maybe it's, you have a company that have millions of documents and procedures and stuff like that, just kind of like everywhere, but no one person understands all of it. Well, in the past, that was kind of useless. It doesn't really help you. But if you can upload it to a model like that, all of a sudden it knows all those things about your company. It can train people on it. It can answer your questions. It can kind of manage it, update it, see if there's any conflicts anywhere in it. So instead of training a brand new model on that, you just use an existing model and upload that stuff into the 10 million token context window. Combine that with text to action, which is another word. I've heard it before, this phrase, but it's not that often used, I feel like. But yeah, I mean, that's what agents are basically, right? It's text to action. You type in a prompt and it goes and does that action. It does the thing you're asking it to do. As they get better at long-term planning, long-term reasoning. And actually, DeepMind's CEO, Demis Hassabis, also just had an interview talking about something very, very similar. He's talking about this idea that as agents become better long-term reasoners and planners, they will become better and better at carrying out those long horizon tasks. And he's saying we're not ready for it when everybody can have these qualified, capable agents, right? He's saying it's going to have an impact on the world at a scale no one understands yet. And that certainly, I think, is true. That's certainly something that I fully agree with. A lot of our social structures and stuff we're kind of used to will have to change. And of course, he's saying if you're worried about losing your job, having a degree that's going to become worthless, should you still learn to code? He's saying business as usual there. Yes, some easy, simple jobs or maybe very dangerous jobs, jobs where there's not a lot of hard decisions to be made, yes, those might go away. And yes, these AIs might be pretty good at coding, creating projects, but learning all those skills, getting better at those skills, learning how everything works, that's not going out of fashion. That's never gonna just disappear. His example was, if you can speak English, why would you learn English, right? Why would you study English? Well, it's to get better at it, to improve your abilities with it. So I hope you enjoyed that. Make sure you're subscribed. Please give me a thumbs up if you enjoyed it. My name is Wes Roth, and I'll see you next time. Thank you for watching.